I am Brinda and going to do a small presentation on tunnel diode. A tunnel diode or SK diode is a type of semiconductor that is capable of very fast operation well into the microwave frequency region made possible by the use of quantum mechanical effect called tunneling. It was introduced by Leo SK in 1958. Heavily doped PN junction. Impurity concentration 1 part in 10 power 3 as compared to 1 part in 10 power 8 in PN junction diode. Width of depletion layer is very small, about 100 Armstrong. It is generally made up of germanium and gallium arsenide. The circuit symbol of tunnel diode. Circuit symbol is like PN junction diode, but the cathode looks like the tunnel. The arrowhead indicates the conventional current flow when the diode is forward biased. Tunnel diode or SK diode is a thin depletion layer diode which has negative resistance in forward bias condition. For the construction, only PN diode is constructed by adding one impurity atom for every 10 power 8 semiconductor atoms. With this order of doping, the depletion layer width is high and there exists a barrier potential across the junction. Due to this barrier potential, holes from P region and electrons from N region cannot cross the junction. Tunnel diode is constructed by adding one impurity atom for every 10 power 3 semiconductor atoms. The depletion layer width is inversely proportional to square root of impurity concentration. Therefore, in tunnel diode, the depletion layer width is less than or equal to 100 Armstrong. Tunneling. When the depletion layer is very thin, electrons cannot move from filled state to empty state without any additional energy. This phenomena is called tunneling. Here are some conditions for tunneling. The diode should be heavily doped. The depletion layer width should be very thin in the order of 100 Armstrong. There should be filled state in one side and empty state in other side. The filled state and the empty state should be on the same energy level. Forward bias operation. Under normal forward bias operation, as voltage begins to increase, electrons at first tunnel through the very narrow p-n junction barrier. Because filled electron states in the conduction band on the n side become aligned with the empty valence band, hole states on the p side of the p-n junction. As voltage increases, further these states become more misaligned and the current drops. This is called negative resistance because current decreases with increasing voltage. As voltage increases, yet further the diode begins to operate as a normal diode, where electrons travel by conduction across the p-n junction and no longer by tunneling through p-n junction barrier. The most important operating region for the tunnel diode is the negative resistance region. Reverse bias operation. When used in the reverse direction, tunnel diodes are called back diodes or backward diodes and can act as fast rectifiers with zero offset voltage and extreme linearity for power signals. They have an accurate square law characteristics in the reverse direction. Under reverse bias, filled states on the p side become increasingly aligned with empty state on the n side and the electrons now tunnel through p-n junction barrier in reverse direction. This is the equivalent circuit of tunnel diode when biased in negative resistance region. At high frequencies, the series R and L can be ignored. Hence, equivalent circuit can be reduced to parallel combination of junction capacitance and negative resistance. Some of the applications of tunnel diode are: it is used as logic memory storage device, it is also used as microwave oscillator, it is used in relaxation oscillator circuit and used as amplifier and ultra high speed switch. Advantages of tunnel diode. Very high speed. The high speed of operation means that the tunnel diode can be used for microwave RF applications. Longevity. Studies have been undertaken of the tunnel diode and its performance has been shown to remain stable over longer periods of time, where other semiconductor devices may have degraded. Some of the disadvantages of tunnel diode are reproducibility. It has not been possible to make the tunnel diode with a reproducible performance to the levels often needed. Low peak to valley current ratio. The negative resistance region and the peak to valley current is not as high as it's often been required to produce the levels of performance that can be attained with other devices. Thank you.